Everyone. In this video, we're going to talk about the different types of numbers that humans have invented since ancient times. And we're going to talk about how these sets of numbers build on themselves in a logical way. So, the first set of numbers that we have are the counting numbers. And when ancient humans invented symbols to represent amounts, it's logical that they first invented counting numbers because these numbers can be used to describe different amounts of objects that you have in real life. Like you could say, I have 3 people in my family, or I have 7 apples, or I have 5 sheep. So, the counting numbers are really useful for describing different amounts of objects. And at some point, some human asked and said, well, what about when you have nothing? Like if I have 5 sheep, that's great. But how am I going to describe it when I have zero or no sheep? And I kind of gave the answer away because they invented the number zero to describe the amount of having nothing. And when you combine the set of counting numbers with the number zero, that creates the set of whole numbers. And if you take any two whole numbers and you add them together, you'll get another whole number. Like you could say 5 plus 3 equals 8, or 1 plus 7 also equals 8, or 11 plus 27 equals 38. I chose a lot of numbers that happen to add up to things with eights in them. But basically, if you take any two whole numbers and add them together, it equals another whole number. However, this is not true when you look at subtraction, because sometimes when you take whole numbers and subtract them, you'll get another whole number. Like if you do 5 minus 2, that will give you the whole number 3. But other times, if you subtract a smaller number, or sorry, if you subtract a bigger number from a smaller number, then it does not create a whole number, like if you do 2 minus 8. And so, this idea that subtraction is, or excuse me, that whole numbers are not, and this idea that the set of whole numbers is not closed under subtraction made us invent the next type of number, which is the integers. So the integers include all of the counting numbers and the number zero, and it also includes all of the negative versions of the whole numbers. So, like -1, -2, -3, and so on. And by defining the set of integers in this way, we can say that the set of integers is closed under subtraction. Because if you take any two integers and subtract them, then you will get another integer. Because if you did like 2 minus 8, that would give you the number -6. So that was the next type of number that was invented. And if you take any two integers and multiply them together, you will get another integer. Like if you do -5 times -4, you get a positive 20. Or if you do positive 2 times -4, you get a -8. And we'll talk about in future videos why that's true and why a negative times a negative equals a positive. But the basic idea is that any two integers, if you multiply them together, will equal another integer. So the set of integers is closed under multiplication and subtraction and addition. However, it is not closed under division because if you took two integers like 1 and 2 and you did 1 divided by 2, the result would not be another integer. And so this motivated the creation of the next set of numbers, which is the set of rational numbers. So the set of rational numbers is defined as any number that can be written as a over b, where a and b are integers and b does not equal 0. So any integer can be written as a over b, because if you wanted to write, say, the number 12 as a fraction, you could write it as 12 over 1, and that would be the same thing as 12. So the set of rational numbers includes all of the integers, which includes all of the whole numbers and all of the counting numbers. So the set of rational numbers is closed under division and multiplication and subtraction and addition. And if you take any rational number and multiply by itself multiple times, you end up with the operation of exponents, or at least whole number exponents. And because rational numbers, or the set of rational numbers, is closed under multiplication, that also means that it's closed under whole number exponents. However, if you do the opposite of exponents, which are roots, and we'll just look specifically at square roots, but there's also things like cube roots as well. But if you try to find the square root of a rational number like the number 2, which also happens to be a whole number and an integer and a counting number, the square root of 2 cannot be written as a fraction a over b, where a and b are integers. And so this gave rise to the idea of irrational numbers. And then when you try to find the square root of a negative number, that gave rise to the idea of imaginary numbers. So there's also other categories of numbers beyond these, but these are the main ones that we'll cover in this class. And to summarize the way that they're related to each other, you have counting numbers, which are like the numbers 1, 2, 3, 4, etc. And then when you include the number 0 with all of the counting numbers, that creates the set of whole numbers. And then when you include the negatives, like -1, -2, -3, and so on, that creates the set of integers. So the set of integers includes the whole numbers, which includes the counting numbers. And then the rational numbers also include fractions like 1/2 or 3/4 or -12/15, and so on and so forth. So the rational numbers are any number that can be written as a fraction of whole numbers. And then the irrational numbers are the real numbers that cannot be written as fractions. So some common examples would be things like the square root of 2, or the number pi, or the number e, if you've heard of Euler's number. And basically the square root of any number that is not a perfect square. Because like if you did the square root of 16, that would equal 4, which would actually be in this category. But if you do the square root of a non-perfect square, then it will be an irrational number. And the combination of the rational numbers and the irrational numbers make up the real numbers. And then we also have the imaginary numbers. And there's, like I mentioned earlier, there's also other numbers, like if you take a real number and add it to an imaginary number, that makes a complex number. And then there's also numbers like the hyperreal numbers, and other sets of numbers like that. But those ones aren't particularly useful, at least at the elementary level. So, the main focus of elementary school will be on the rational numbers and all the numbers within that set. So, you may introduce negative numbers if you teach an older grade. In the younger grades, they're mostly just going to focus on whole numbers. And in the middle grades, you'll start introducing fractions. So you won't really get into irrational numbers until middle school. So we won't be doing a lot of that in this class. And we also won't be talking very much about fractions because there's another class that covers fractions. But we will be talking about integers, and the relationship between adding and subtracting, multiplying and dividing integers. So that's just a quick summary of the different types of numbers. If you have any questions, let me know. And I hope you have a great day.